Okay.
Okay, welcome. So what's Printf about? I mean, I think you have an idea that the Printf project, I mean, implementing Printf it's about you being able to write your own function that will emulate the standard level function called Printf, that will behave like it to the extent to which you want to behave like it. What do you want to behave like it completely? You want some things to be, I mean, you just know. For example, we have a function that is standard library function that we call putcar, as I said in name, put character. We put a single character, a print single character to the standard output. you know we have put s as well. Some people call it puts. So this one, you could write this. Somebody should help me now. This is the part where I need to be actively involved. I want to write a function, putka, that puts a character in the string, that prints a character, so character at a time, one character at a time to the string. So let's go from the prototype or from the declaration of the function, every block of code. Somebody help me. Hello. I hope I'm still in the call.
Yes, you are in the call.
All right, so talk to me, somebody, because you're taking Printf now. You want to face this one thing, we should be able to.
What's the question, please?
Grind the heat, the small heat.
What's the question?
I want to emulate Putka. We want to write our own function on my Putka that gives like Putka, the standard library Putka.
That will be int my one can then inside the parentheses.
Your line is breaking.
Okay, a character inside the parentheses. You can just make it character A or character B or C. Just taking one character inside the parentheses.
Okay. All right. Okay. What follows, please? Someone can pick it up from there.
We will put a write function from the Universal Standard Library.
Okay, that means we need to include the library hash include ini the right function.
So I'm hearing you.
The network is breaking from his own side.
You're not hearing me?
We can hear you now. We can hear you now.
Please hold on. Let me refresh my net. Better. It's not cracking again. It's not breaking again.
Yes, it's not breaking again. It's not breaking again.
Okay. So I'm not sure how to get this guy now. Let's see. Is it man 2 right or man 3 right or man right? This is the mono. This is what we want. Send the message to another user. No, this is not what we want. Man 3 right. Okay.
Yeah. It's not
Man 3 right.
Okay, it is
okay.
Okay, yeah, this is it.
All right, so you can see that this tells us what it does. From the description, you can tell that the write function it attempts to write number of bytes from the buffer pointed to by boof. Look at boof here. It has two different prototypes, as you can see, and then to define associated with the open file descriptor. Like this, I don't want to be doing all of this because there are plenty of YouTube videos that can do all of this. So my own is to do something unusual, something that is not doing the way that is not done there out there, so that this class will not be something like a Greek has done speaking Arabic, speaking language you don't understand. But I'm trying to point out here that this guy takes 1, 2, 3, 4 arguments here. Here it takes 1, 2, 3 arguments. So which one are we using? And they're saying that it prints n bytes. So that means we can determine the number of bytes that it prints. And we are trying to emulate a certain standard library function that prints only 1 byte per time. Remember that each car occupies 1 byte. Those things you learn as basic, don't forget them. You always need them. You need them throughout the journey in this career. Okay. All right. So that's just by the way. So what do we do here? Let me just, before I start talking something too deep, we are talking Printf. What do we do here now? Are we using the prototype with 4 arguments or with 3 arguments? In fact, in this model, you're supposed to show us the library, header file where it is found.
Yeah, scroll up. I think you passed it already. It's always video at the top. That's it. After the synopsis.
Okay, as it include. I was wondering. So great. So these are things you want to do. You don't want to read through everything. You may go crazy. look for what you want and read that thing and understand it. You don't need to have 100% understanding to be able to work with it. Just understand it a bit. All right. What do we do now? What do we do? What is the first argument? What is the next argument? What is the other one? Okay, let's leave that by the way. Now you understand that if we get this thing right, it will be working like the standard library putcar. Meanwhile, we don't know what is written in the standard library putcar. I don't know how they wrote it. I have not batched into any document at all revealing the source codes of any of those standard library. I don't know. I stand to be corrected. I've not seen. In fact, if there was one for this printf, we wouldn't be separating ourselves writing printf. We just go there and copy it and paste it. It will be useless implementing our own printf. It will be very useless except we want to modify the one that exists already. As is happening in Python, people are adding codes to Python, adding models, making things easier. Now, this is something similar. Now, having known how putcar works, we now know what we want here. Even if you seem to be unable to give me exactly what should be inside here, but now you know what we want. Now I want to put something inside this right that will make it print only 1 character per time, one character per time, and we want to make that our return value, of course. So we need to have something like this return. So inside the parentheses for the return value, you now put the right function there and say this is what you return. And of course inside here, as you can see in the prototype here, we're using this second one. We are going to determine. Hello, can I make it yet? We are going to determine the size. This is like the data type size t of the bytes. So we're going to split that. It has to be 1. This is why we state that print only 1. Print 1 or something contained inside this buffer. That's by the way. Now,
please, what is a buffer? What is a buffer, please?
Buffer is like what layman term should I use now? Bucket, container. It's just like a container, yes. Buffer. So someone can help me. Who has a better explanation?
A temporary storage for strings. So that is what we call buffer. A temporary storage for strings. So anytime you are storing strings, so a temporary storage for strings. That is what we call a buffer.
Okay. So it's meant to contain some characters or array of characters, temporarily. Talk about temporarily. Wow. Okay, let's go with that. So for printf, now if you take a look at this code and see how now you understand better when you see something that resembles putcar but is not putcar. written by you, used to implement. That's how this guy called printf is defined in a certain standard library known as, who wants to help me?
Is it stdio.h?
Okay, ask question you're asking me to. Asking me easy.
STDI the paper.
Okay.
Standard library.
So what does stdio.h mean?
Standard input output.
Thank you. So STD for standard, I for input, O for output, H for header file. So standard input, output, header file. All right, you're making progress. Then we want to now unveil the secrets of printf. Who is this guy printf? How does it work? Because we need to know how it works for us to be able to write something that will work like it. You know, referring back to Putka that we just mentioned now, we've seen that Putka, it does nothing but print a single character at a time. It cannot print integers. Try it, you drop an error. It cannot print a string, even though it's just two characters joined together. It cannot. It will drop an error. You know, it will be doing it. So having known that thing about it, we are able to write our own with this. I think write is a system call, right? Write is a system call. You some of us, or most of us, have learned about it. Now, the next thing you want to understand is, first of all, what I think we want to begin with the prototype of this printf. What is its return value? You know, what is the return value? How does it work? Because printf is a unique kind of function. You don't give it, it's not a function that you give the same amount of value, amount of argument every time. You could give multiple variable amount of argument to printf. What I mean by that, if it sounds strange, is that okay, I think we have it on the screen here. You can see that this guy is a function now. At this point, we declare the function int. Int is a return type, so it returns an integer, you know, and then that is supposed to even spark some question in you. How is it returning integer when it's printing character? How come? That's by the way. Okay, so it has only one argument. It takes only one argument. Okay, only one argument. But printf, this is the prototype. If I'm not mistaken, it has a constant format. Okay, how am I even guessing? Let's look for it here. Printf format argument. Do I need to do monthly printf again? Okay.
I think it's man 2 or man 3, one of the two.
Okay. Let's try man 3.
Yeah.
All right, here we go. All right. So yeah, you can see members of his family, but you are interested in this one, not fprintf or sprintf. There are several of them, man. This is where we say no one knows it all. So this is what you're interested in. Let me copy it and paste it here. This is a prototype. Remember that act of, okay, I don't want to mention some names. I don't want to say some kind of things here. Some kind of things here. So I don't I don't stop this video from going far and wide. But you may have encountered some occasions in your life where you have to write some functions and you are given the prototype. You know, you're given the prototype. So it even makes things easier for you when you're given the prototype. Of course, there are cases where you could have used another prototype. You can use different. I can write same. You can write same function, a function that performs the same thing with different prototypes. It's very possible. Very possible. So this is a prototype. It means we already have an idea now, and this is where knowledge of variable functions comes to play. You know, the ellipsis here means that it will take variable number of arguments, the first of which is a constant let's say string, a string that is constant, a string that once you give it to it, nothing changes it, and then it takes a variable. That means there is no limit to the number of arguments you could take. That's what this means. You could take multiple. You could take 2. You could take 3. You could take 4. You could take 5. You don't hinder it. That makes me feel like talking about variable function, but let's just keep going. Just keep going. Let's talk about printf. Now, what does printf do? Now, let's try using printf here to do. Where am I? I need to. Okay. Okay, I'm going to make a directory called come on, printf class. Let me be equal to. What do you think happen is equal to? Is it possible to use equal to the name directory? I've never tried it before. What will happen?
I think it's possible. I'm not sure.
Let's see.
Yeah,
Wow.
characters. So
Wow, it's not even serving like a link. It's making the word, it's making it 2 words. All right. Okay, so I want to rather have it as printf class. Actually, it's every opportunity to try new things, especially when there's no Cosmos. I want to move into that file. That's where I'm going to be working. Watch this. The printf you're talking about, as a capacity. This is how it functions. Like, let's start. I'm going to create a file called printf. Let's see. Let's play with the printf function and see how it really works. What can it do? How does it really work? Let's find out whether there's something that it can do that it's not easy to do. So I'm gonna have my main function here. So in this block of code, pay attention to it because it's being recorded. The code will be changed. I'll be altering the codes as we make progress. So let me have my return value first. You can see what we return integer. That's by the way. Let me not deviate. So, active come. Active started. Okay, now let's go printf. You all know that if I do printf, of course the first argument is usually a string because you can see that from the prototype here. It takes, when you see car and see this asterisk, let me not assume that we all know. When you see car and see this asterisk, what does it mean? Because here we did car and there was no asterisk there, just car A. But here we say car asterisk format. What does it mean, please?
It means it's the pointer.
It's the pointer. Okay. Who wants to add to that? Thank you very much. Who wants to add to that?
It is a string. So it is an array of string. So it is pointing to a string. And that string is immutable. It cannot be changed.
Okay. Okay, thank you. Now, note that it is not just pointing to the entire string, it is pointing to the first member, the first character of the string. You recall that, I believe. It's pointing to the first character. So that's what makes it function like a pointer. So why? Because it's pointing to the first character of the string, you can now access other members of the array of characters, from it by manipulating that very first address. So that tells us that this is the reason why the first argument you give to printf is a string. It must be enclosed in 2 double quotes. I believe you know this. Now, when you put comma, this comma is likened to the comma you put to separate 2 arguments in any function. No, let me put a comment here. Assuming you have a function that adds two numbers and you put let's say it adds three numbers and you say it takes three arguments, int A, comma, int B, comma, int C. You know, so that comma you're seeing there is what is something that all the commas in printf stands for. So if I'm calling this function add now, let's say I'm calling it in a program now, it will look like this. I won't be putting int again. I'll be calling with numbers or variables, of type int. So I say add 3, 2, 1. If this is a real function that adds 3 integers, it should add this in and give me 6. It should add this and return 6 to me. So this is the first argument. 3 is the first argument here, or the first parameter passed to it. 2 is the next one. 1 is the next one. So also is string the first argument passed to printf. So whatever you put in that string, we print. Hello, go try. We print the way you want it to print, except for the fact that there are special characters. There are characters that are very special. Now you can take only one argument. You know this. You did the Hello World project. You did the Hello World. You did the Hello World program. You wrote Hello World program. I don't know why it's always Hello World. Every time Hello World. But it's fine anyway. So this will print. If I decide to put apostrophe here, this should print. You want to confirm? Try it on your local. You can try it now and find out where to print like this. There's nothing special about that apostrophe that I added there. But of course, you don't want to. Okay, let me take it bit by bit. I said there are characters that are naturally special. They are special. So anytime they come in with their attitude, that's their capacity to function spatially. And I'm talking about characters such as, let me open, okay, I think I should use my board. I'm talking about characters such as, now I'm not careful about using the right terms anyway. I'm trying to make sure I communicate it very well. So spatial may not be exact term to use anyway, but that communicates it very, very, very well. So we're talking about things like backslash, and then we're talking about something like, what will help me? Give me some more. Someone unmuted, so talk to me. Characters that are special, they are so special, like they are not ordinary. You cannot just use them in printf. Someone has to talk.
Ash,
are you sure?
Yes.
Ash, please. It's okay, we'll find out. Some more. That is what you use every day.
Percentage.
Aha, thank you.
Yeah.
That's actually more. Okay, well, let's go with this. Okay.
Is it F floats? Okay, no. That was not character.
Okay. So I'm talking about a single character that when you use it inside here, it becomes. So what happens when we use any of these guys inside here? What happens? Now that will make me want to run this program. Okay. Forget about. Remember that this. Okay, let me take this line off. I think we're through with this explanation. And this comment here. Let me take it off. And then so this is our program, not corrupted, nothing added. So I'm going to save it. Maybe I should have another. Okay, I'll just save it or close it. And here it is. I'm going to. Oh, Emacs has already given me duplicate copies already. So with f.c, I want to save the output into a file called demo. So it compiles that error. That's it there. Demo. So I want to run it. Not add new line. Just remember now. So drive. Sorry, that's very nice. Let me add a new line character. If it's Johnny, right? If it's Johnny, you're getting somewhere. Okay, I'm going to call back the command I used earlier. Then I'm going to run it again. So it prints hello code tribe. Now let's see what will happen if we try to use any of these characters here. Let's see what will happen. I'll just try one. You want to know what will happen about all the rest? Try by yourself. But I'm very interested in that hash. I'm very interested in that hash. So if you print like a normal thing, then there's nothing special about hash after all. So I'm going to put hash here. So close. I'm going to compile again. Compiled. So I want to run the script. Run the hash printed like every other character. Thereby is proving the fact that is special. Hope you got that. Now, I'm taking hash away from this list. Oh, let's not try something else. Let's try double quotes. If I want to say hello, double quotes, tribe, double quotes, you can see that there's job already. You know, it marks the settings, the syntax has shown that only hello will be printed. That is if the compiler, if it will pass the compilation stage, as if it will compile. You know, so I'll go ahead and run this. I'm not going to do all of this, all of the demos. So that's why you need to, you can see errors. You need to practice on your own as well. You know, practice on your own. You can't do all of the practice here, except you want to have the 7-hour class. You know. Okay. Back to our program. And let's talk about apart from these special characters, there are more than 3 actually. I have only 3 on my whiteboard. There are more than 3. Apart from these special characters, there are characters that are ordinary that become special when this backslash is added to them. You want to give me some example?
Like N.
Try again.
T.
R.
Yes. Then B. Yes.
So black slash. Okay.
Then backslash.
Backslash. Okay. Yes. Okay. It becomes special. No, does backslash become special? I mean, the one that becomes special.
You cannot print backslash alone. You have to use 2 backslash.
I'm talking about a kind of such that you can print it alone, but when you add backslash to it like this, it becomes something special.
0.
Is it 0?
When we are printing no character.
Okay. Thank you so much. So when you do this, it becomes 0. But will this thing print on Printf or not? Let's find out. I like those ones that look to me. Those are the ones I test faster. So let's say hello code tribe. And put. Let me put it in the middle and see what happens. Hello. We'll print F because we are talking about Printf right now. We're not talking about C programming. Let's see. I save this. Close it. Compile it. It's running already. And what's this one about?
Backslash O is a null terminator, so it has seen it as the string has ended there. So that is why it is flagging out.
Okay. Now let's establish that fact very well by putting it at the end. So if that's the case, you should not quarrel with us if we have it at the end. Taking this one off from here. Hey, Johnny, and I hope we'll go very far this journey. So Johnny along the path of Printf. So it's also refused to compile. So if it's a no byte, we are giving you no byte now. It's at the end. Let it be the end of the string now. So it means that this guy does not have any business inside printf, so it should not be in our list. There are others. So you want to find add others, okay? You want to find add others that we once you add backslash, they become special. They are ordinary, but once you add the backslash, they
I
become
think
special.
that one you cannot print a null character. It's just used to end a string. So you putting it inside printf statement is you are trying to tell printf to print the null character, and it's never possible.
That's right.
Yeah.
Okay. So let me be sure that we are all following, right? What is happening now? I want to duplicate this. First, I established that this guy takes very number of arguments, and we are talking about the first argument, and the first argument must be a string. And they will start talking about that inside this string, there are characters that print that are very ordinary. They are ordinary. There are characters, let me call it one. There are characters that are special. Let me say naturally special. As single character, nothing added to them. They are naturally special, and there we started using these examples, which you gave me, which we confirm. That's fine. Okay. So when I say that also that there are characters that are ordinary, let me say alternatively special. They're ordinary but become special. Alternatively special. By this I mean they are ordinary on their own, but once you add backslash, they become special. So from what I'm trying to show you that now is that the null byte is not one of them as far as printf is concerned. Remember, printf business is to print something to the standard output. So I'm not asking you for all special characters in C programming. I'm asking you for what printf inside that string, inside this string here, this constant format, this constant character. What it considers. Let me calculate this and make sure that I'm not being too abstract. So inside this double quote here, we are talking about what can be recognized as special, what can become special when backslash is added to it. The ones that are special, you add backslash to make them non-special, like these ones now. Someone was saying that if you want this guy to print, you have to add an escape sequence, the backslash to it. We're talking about the backslash itself. If you want percentage to print, you need to make it 2 or use one escape sequence as well. It will work. Escape sequence using let me demonstrate that. I think I should at this point. So doing backslash percentage, forgive me, I'm not using pen, I'm using my mouse. Backslash percentage and using 2% it produces the same result. I encourage you to practice on your own, try to find out these things, because it will make you understand this journey as you make progress. So I don't get lost at any point. Okay, sorry, I got. All right, so I was saying, yeah. So I'm at this point now where we have established that there are things you put into that string, they just print the way they are. You put space prints the way they are. A, B, C, D, they print the way they are. We've established also that there are things that you put into that string, you are looking for trouble because they are not just designed to be printed like that. They are special. They are special. So for you to print them, you have to add a backward slash, or something to escape them and make them print ordinarily. And we've established also that there are things that are ordinary, or once you add backward slash, they become special. Let's say printf, making progress. Okay, let me experiment with one of these. Let's see how I can print Um, this number, can we even print it? We can actually print something that looks simple out. See, we need to just do something. Someone should help me. I want this number not to print. This one has refused to print. We want it to print now. We want to force it to print. What do we do?
No byte is it is not going to show at all. It is just an empty stuff. If we use putcar to print it, it will just show blank. If we use putcar to print the character, it will just show blank.
What about if we put the forward slash, one forward slash,
backward slash?
I mean, sorry,
Actually,
backward
thank you.
slash. Yeah.
Thank you very much. So let's go and try that. So I go here, and where's that going now? Demo. If not that, if not that is hiding. Wow, this is cool. Man. It's hiding now, but there's no problem again. You have escaped it, and it's maintaining its character now, being invisible.
It's not hiding actually.
It's on the next line.
It's on the next line.
Ooh, I love it.
Your new line character is in between that.
Okay. I would have been surprised if he was hiding. I say, thank God for that. All right, so we just succeeded in making it very ordinary. Very ordinary by putting that escape what. Okay. Okay, that's by the way. Now let's move further. Let's move further. Now let's talk about having this guy having more than one argument. You know, want to experiment with all. Today I used the alarm. You know, backward slash. I was so shocked when the alarm really rang. Was it today or when? I remember, maybe yesterday or today. I was just thinking about it, and then I thought this backward slash A is actually alarm. Asking to sound alarm. And then I compile, I ran it, I had the alarm. I just shoot. So this thing works. And then I try the backspace as well. I try to see how they work, the vertical tab and the tab itself. I've been using tab since, and then some other things. Yeah, they're just cool. They're just cool. And then I saw something like this percentage, and that's by the way. Let's make progress. Now, how then do we now? Are we now? Okay, let's talk about format specifiers. There are another special kind of things that don't print like ordinary characters. They're not ordinary. What makes it? What makes special format specifier is the fact that a special character in Printf is followed by a predefined letter, you know. O, we have B, we have X, we have uppercase X, we have A, right? We have U, we have and U, none of that. Now, these guys, I've discovered that these guys, they are in a way grouped into two. There's some that's talking about length. Let me check whether I can get that stuff here. A prototype of a format specifier. Very interesting. I mean, yeah, it begins with let me see how much I can remember about that. It's something that looks like this. So first you have your flag, you know, and then you have let me put this in a bucket, and then it's followed by what now? Okay, let me just write as much as I can remember. Later I'll write it in the right order. And what? Thank you. Thank you. We have wheat here. And then after position, we have what?
Dot before the precision.
Precision, thank you. Because that makes me believe that it has everything to do with float. All right, length, and then of course the specifier. To make progress, you start appreciating this long int, short words, because you want to. It is you trying to specify the highest possible, or you're trying to give it a range. A range of length that you want it to have. What do I mean by that? Let me show you something. Before we get there, let me just show you how printf relates with other arguments. How the first argument relates with other arguments, which we've been doing, and we've been writing plenty of programs that demonstrate this. So if I come here and say because it's not only variable. Even when I was reading, I was seeing variable. But with practice, I found that I don't even know how I'm ready to do it for the first time. I don't remember how I'm ready to do it for the first time. But it's not only variables that you can pass as second argument. So if I do %s is the format specifier that prints string, right? And now say, okay, this is the string I want you to print. I pass the string as the second variable. Just the way it goes to the first person, it will go to a variable, to go and find the string to print out. That's the same way it will come here and see the string at once and print it out. Let's try that. I'm going to save this, close it, and compile again. Run it. It's printing hello code tribe. Of course I had no new line there, so that's why it's jamming. So let me add my new line inside here as well. Okay, I can add my new line here in the first argument. Anywhere it will work. Anywhere among the two, between the two. So run it again. Hello code tribe is pretty well. In the same vein too, I could go and give the format specifier that prints integer and pass the integer to it as the next argument. So let's do something like this: percentage. Okay, I don't want it to get crowded now. Let me take off this and put a column and say percentage d for decimal base 10, and go here and put comma, and say what I want to print is 20, and come here and put a space, column, and say percentage f, and come here and say comma, I want to print a float value of, let's say, 2. Observe this float. That will happen. How to print it? Okay, this is it. And then after everything, I want you to print a new line. So I'll go ahead and say print new line. I'll save this, close it, compile again, and run the code. It prints hello code tribe. It prints 20. It prints 2.6000000. Now someone help me. I don't want that plenty of zeros there. What do I do? This is where we are trying to use some of these things now. These prototypes, apply them. What do I do? I don't want those zeros there.
You will use precision.
Okay.
In the use the point. If you use the point, then you put like 0.3 or 0.1, depends on how many zeros you want.
I want only 2 decimal place. So what do I do?
To be 0.2.
Where is the point going to be?
It will be on the percentage f. Look.
So after it or before it or where?
After the percent.
Okay.
Yes, 0.2.
Alright.
Yes, sir.
This is us using the precision now. Just pay attention to these things. Like we are trying to familiarize with the behavior of printf. What is it about printf? Because when you know how printf behave, it is then that you can now try to see, okay, I need to write a program that behaves like this. You now start looking for what will I put here to make this program behave like this? What will I put to make this function actually behave like this? What will I put here? Where will I get this? Where will I get this? And then it makes writing printf less difficult as you make progress. You know, I think it makes it not to be scary again as it used to be in those days. Okay. Let me compile now and see if that works. My God. I don't understand this embarrassment too. I'm supposed to have like parts of line now, but it's gone. Like, oh, I still have 30 minutes to go and I don't have any backup plan. No. A demo. That's it now. It's printed 2.60. Now, in the same vein, we can determine not just for float, even this integer, we can state how many values we want by default. Look at that. I said we can state. Let me go back to my board because my this is about to go off. Let's see if it does go. I think I would say this and end here because of my battery. Right, I'm out of power. Okay. We can state the width we want. I mean to say that we can say, okay, when we print 20, you know, keep space for what will I use now? Let me use this. Keep space for two numbers before you print 20. We can centralize it. We can say keep space for 2 digits before after 20. We can choose to feed that digit with something, you know, and say, okay, put let's say something else here and print 20. So because I want this particular I want to customize this guy to be printing to have the 6-digit mentality. We can also customize it to have zeros and say, okay, say I want it to be 6. So I'll print 4 zeros, 1, 2, 3, 4. But imagine us customizing, let's say phone number. Okay, mobile number will not be a good one because we are from different countries and we have different am I still in this companies?
Yes, sir.
Thank you. Okay, let me use dates now. I want to customize month to be 2 digits. So if you write a program that's asking someone to enter the month, that month, the person enters 2, the thing automatically put 0 between it before the 2 because it has to be 2 digits. You say what's your birthday? This person say 91. Then your guy will add 91 where you want it, what you want to be there. Okay, this one is different. This one you can use normal ordinary string to do it. And so I'm talking about using a particular character. So you can determine the width of a character. You can determine the alignment. You can say, okay, I want the 0 to be after the 0 should go this way, 1, 2, 3, 4. It should go rightwards. You can justify it, make it left justify, right justify, centralize. But before my objective will embarrass me and end here, I think I need to end here. I don't know whether there's any quick question I can quickly take.
Sir, I have a question.
Yes.
Yeah, would you be continuing the class tomorrow or later today?
Okay, it is. I don't have plans to continue tomorrow, but it's a series actually. It's a series, so we're going to be building on this as we keep making progress. Building on this, I do hope that we get to the point where we end up implementing our own Printf. I'm saying I do hope because honestly, I can't tell exactly what nation looks like. I can't tell what projects is for me ahead. I can't tell whether to give me the breathing space, but I will do as much as I can do, and I'm going to learn a lot in this series. Okay, so any other question? You will get informed, right? But when the start to hold.
Okay, sir.
Wow, to the two persons refusing to sleep. Okay, I just want to say thank you very much for uh, being part of this section. Thank you very much. And you want to read about it, so you come.